Welcome to Electrical Lad, your trusted source for simplifying electrical, hydraulic, and pneumatic concepts in a clear and practical way. If you're new to this channel, don't forget to subscribe and tap the bell icon to stay updated on our latest videos. Working with fluid power and electricity can be dangerous, so make sure you're properly trained before handling these systems. Hydraulic systems are the backbone of industrial machinery, but when they fail, finding the root cause can be frustrating. After 30 years of troubleshooting, I've seen both common and not so common problems repeat over and over. In this video, we'll cover 10 hydraulic failures, the symptoms that signal trouble, and how to troubleshoot each one step by step. By the end, you'll be able to diagnose and fix hydraulic issues with confidence before they lead to costly downtime. Let's get started. Symptom 1. Pressure switch does not activate at the set pressure. Certain hydraulic systems, such as foundry molding machines and hydraulic presses, rely on reaching a specific pressure to complete their cycle. A pressure switch ensures this process happens correctly. If the switch fails to activate, the cycle times out, causing the cylinder to retract before the process is complete. Run the cycle once and monitor the pressure gauge to see if it reaches the set pressure. If the gauge shows the correct pressure but the switch doesn't activate, replace the pressure switch. However, if the pressure gauge shows a lower pressure than the set pressure during the squeeze or press cycle, it's likely due to a directional valve leaking to the tank when it shifts. Sometimes you might mistakenly suspect that the cylinder piston is leaking and bypassing oil to the blind end during the cycle. However, if that were the case, there would be other symptoms such as cylinder drifting. Symptom 2. Cylinder extends but does not retract, and we have system pressure. This is almost never a flow control issue, unless the flow control valve is set to maximum restriction, in which case the cylinder will still retract, but very slowly. So what is the issue? First, ensure that power is reaching the coil. Check the fuse. If it's blown, this indicates a shorted solenoid coil. In that case, replace both the coil and the fuse. If the solenoid is receiving power but the cylinder does not retract, try manually shifting the valve. If the cylinder retracts when manually shifted, this indicates an open coil and the solenoid should be replaced. If you manually shift the directional valve and the cylinder doesn't retract, it could mean the valve is bypassing oil to the tank. But what if that's not the problem? What could it be? Here's something you might not expect. In rare cases, the piston could actually be separated from the rod. When this happens, shifting the valve might make the piston retract, but the rod stays right where it is, giving the illusion that nothing is moving. To troubleshoot, start by replacing the directional valve. If that doesn't fix the issue, it's time to replace the cylinder. Symptom 3. Cylinder retracted but fails to extend, and there is system pressure. By the way, if you're finding this video helpful, make sure to subscribe, give it a thumbs up, and hit the notification bell so you never miss our future tutorials. Again, ensure that the coil B is receiving power. If there's a fuse in the circuit, check whether it's blown. This usually indicates a shorted solenoid coil. In that case, replace both the fuse and the coil. If the solenoid is receiving power but the cylinder doesn't extend, try manually shifting the directional valve. If the cylinder extends when the valve is manually shifted, this indicates that the coil is open and the solenoid needs to be replaced. Now, if manually shifting the valve doesn't make the cylinder extend, the most likely cause is that the valve is bypassing oil to the tank when it shifts. In this case, you should replace the valve. Another problem, though rare but worth mentioning, is an issue with the counterbalance. Check the counterbalance pressure gauge when the directional valve shifts to the extend position. Make sure it's set to the design value, because if it's set too high, the cylinder might not extend. Symptom 4. Cylinder does not extend or retract, and we have system pressure. Since we have system pressure, it's almost always an electrical issue, about 99% of the time. The problem is usually either a blown fuse on the incoming side of the PLC output card or a faulty output card itself. Start by checking the fuse. If it's blown, replace it and run the cycle again. If the fuse blows again, That's a clear sign the PLC output card is bad, and you'll need to replace the card. If the fuse isn't blown and the output card is fine, there's a less common issue to consider. Sometimes, if the hydraulic oil is contaminated or dirty, the spool inside the valve can get stuck in the center position and fail to move. In this case, you'll need to replace the valve and replace the hydraulic oil and the filters. Symptom 5. Chronic packing gland failure. In many horizontal or vertical hydraulic systems, like presses, cylinders are guided by four-post guide rods or gibs. If these guide rods become misaligned or worn out, the cylinder rod can extend or retract at an angle. This puts extra stress on the packing, which will eventually lead to packing failure. Check the guide rods. If they're worn, they need to be replaced. Make sure the cylinder and guide rods are properly aligned to prevent packing failure. If alignment isn't the problem, there's another common issue that often goes unnoticed, and it could even be considered a design flaw. This usually happens with overhung loads. Here's the situation. If the system has a flow control on the rod end side, which is typically metered out, and it's turned down too much to slow the extend stroke, it can interfere with the counterbalance valve operation. Since the rod end piston area is smaller than the blind end, a sudden valve shift can cause a pressure spike on the rod end. Over time, this pressure spike can lead to packing gland failure. The solution is to replace the directional valve with a proportional valve and get rid of the flow control altogether. Another option is to replace the flow control with a two-way proportional valve. The advantage of a proportional valve is that it can be ramped up or down smoothly, which helps reduce pressure spikes on the rod end. This way, you can avoid packing gland failure caused by sudden pressure changes. Symptom 6. Cylinder extends or retracts too slowly, and we have system pressure. If a pressure or return filter gets clogged, it can slow down the movement in both directions. In this case, you need to check which filter is dirty and replace it. Not all pressure and return filters have a bypass, especially in systems where contamination control is critical. This is because allowing unfiltered oil to pass through can damage sensitive components. However, all filters should have a contamination indicator or switch to alert you when they're dirty. Symptom 7. Overhung load drifts down, and we have system pressure. The first possible cause of this problem is a very small leak at the rod end of the cylinder before the check valve. If there are no leaks, it's likely a major issue. The cylinder piston seal is worn out, allowing oil to bypass to the blind end of the cylinder. In this situation, the best solution is to replace the cylinder. Symptom 8. Cylinder drifts forward, horizontal load. There are two main reasons this could be happening. First, if the center block valve is leaking internally, it can let oil flow into both the blind end and the rod end of the cylinder. Since the blind end has a larger surface area than the rod end, this creates a force imbalance, causing the cylinder to drift forward. The second common cause of cylinder drift is internal leakage past the piston seals. Even when the valve is in the center block position, oil can leak from the rod side to the cap side within the cylinder, causing it to drift. Start by replacing the directional valve. If that doesn't fix the problem, then go ahead and replace the cylinder. Symptom 9. No system pressure, but the motor is running. There are usually three main causes for this problem. 1. The relief valve could be failing, allowing oil to bypass back to the tank. 2. The pump might be sucking air, preventing it from reaching the set pressure. 3. The pump itself could have failed. Start by checking the tank for foam, as this is a sign that there's air in the system. This can happen if the suction strainer is clogged or if the pump is sucking air through a bad seal. If you find foam in the tank, clean or replace the suction strainer first. If that doesn't fix the issue, replace the pump and make sure it's properly aligned with the motor. If there's no foam in the tank, the next step is to replace the relief valve and check if the system can reach the set pressure. If you still can't achieve the correct pressure after replacing the valve, the problem is likely a failed pump, and it should be replaced. Symptom 10. The oil is getting too hot. Most hydraulic systems use a return line cooling system, where oil passes through a cooling unit before returning to the tank. Larger systems may have a kidney loop cooling system. When oil gets hot in a return line cooling system, it's usually due to one of two causes. If there's no temperature-activated valve, The problem is often a clogged heat exchanger. In plate heat exchangers, buildup can block water flow, while in tube heat exchangers, mineral deposits can restrict flow or reduce heat transfer. If the system has a temperature-activated valve, check that it's opening the water valve at the set temperature before replacing the heat exchanger. A kidney loop cooling system has its own pump that circulates oil through a filter and heat exchanger. If the oil heats up in a kidney loop system, start by checking the pump. If the pump is running and there's proper flow, follow the same troubleshooting steps we discussed for the return line cooling system. I hope this video gave you a clear understanding of the most common hydraulic failures and how to troubleshoot them. If you have any questions or want to share your own troubleshooting tips, drop a comment below. If you found this helpful, don't forget to like and subscribe for more practical tips on hydraulics and industrial systems. Thanks for watching, and I'll see you in the next video.